Hello students. So today we are going to study about trigonometric ratios and its identities. Here we see three new words: trigonometric, ratios and identities. So first we should have the knowledge about what is trigonometry. So trigonometry is basically a branch of mathematics. It is a branch of mathematics. And what do we study in this branch of mathematics? We study about angles, triangles and its application in mathematics and day-to-day life, obviously. So moving forward, for having the knowledge of trigonometry, one must know or one must have the basic knowledge about triangle and geometry. So what is and which kind of triangle? The triangle mostly used here is right angle triangle. Suppose this is angle theta and this is 90 degree. So it is a right angle triangle. And about the geometry, we will know about all this in upcoming slides. So knowledge of triangles. Here triangle ABC and it is a 90-degree triangle, right angle triangle. It is a right angle triangle. How we can say that it is right angle triangle? Because this angle is 90 degree. Okay. And if we assume this as theta and this is a ABC is a right angle triangle where angle B is equal to 90 degree. So we know that by Pythagoras theorem, what do we know by this theorem? We know that hypotenuse square is equal to perpendicular square plus base square. Okay, so hypotenuse square is equal to perpendicular square plus base square. What is the perpendicular here? What is the base here? And what is the hypotenuse here in this triangle ABC? So the side in front of the 90-degree angle is this is the hypotenuse. The side in front of the angle which we are considering is the perpendicular and the side adjacent to it is the base. So here the hypotenuse is AC square is equal to what is the perpendicular? AB square and what is the base? BC square. So this is the basic Pythagoras theorem which we are going to use through entire journey of trigonometry. Okay, now the second part was geometry. So we should have the knowledge of geometry. So what in geometry? Should we know the entire geometry here? No. We should have the basic knowledge about the quadrant. Okay. What is this quadrant? Let me correct this. It is minus x and it is minus y. Okay. So what is quadrant? Quadrant is actually the area of 2D Cartesian system which divides the plane into four equal parts or four regions. Suppose this is a region. Okay, this is a plane and we see that this line x minus x, y minus y is dividing this plane into four regions. So this region is being divided into four parts and it is the Cartesian plane and which is divided into four parts. So these four parts are known as quadrant. This is the first quadrant, this is the second quadrant, this is the third one and this is the fourth quadrant. Okay. So in the first quadrant, we see that the value of x goes right and the value of y goes upward. So both are positive. In second quadrant, we see value of x is negative whereas value of y is positive. Similarly, in the third quadrant, we see both the values are negative and in the fourth quadrant, value of x is positive and value of y is negative. So this much knowledge of quadrant is enough for chapter of trigonometry. Now assumptions in trigonometry. Okay, why we are going to assume something. Here a new chapter, we are starting a new chapter and in every new theory there are some assumptions on which whole the theory is based or the derivations or the proofs are made. So what are the assumptions here? What assumptions were made? First assumption was that sine theta is equal to perpendicular upon hypotenuse. Second was cosine theta is equal to base upon hypotenuse. And third was tangent, also known as tan theta, is equal to perpendicular upon. These are the three most important assumptions in trigonometry on which the whole chapter of trigonometry is based, or whole branch of maths is based here. One more thing we should keep in mind, that inverse of sine is cosec, inverse of cos is sec, and inverse of tan is okay. Inverse of sine is cosec, inverse of cos is sec, and inverse of tan is cot. Okay, here I have written tangent and here I have written tan. So don't confuse in between the words. They both are same. Cosine and cos, sine spelling, just look at the both spellings which I have written here, which I have written here. Okay, here. So these are the basic things which we should know before studying the trigonometry. These were the basic. The assumptions about the quadrant, about the right angle triangle, about the Pythagoras theorem, and the value of x and y, in which quadrant they are positive, in which quadrant they are negative. Okay. So what is trigonometry, or how we proceed in trigonometry? After knowing about the assumptions in the trigonometry, so here begins our topic, trigonometric ratios. What are these trigonometric ratios? We have seen three things in trigonometry, that is sine, cos, and tan. So at different angles, these have different values. How to calculate these values? We will study this thing under trigonometric ratios. For this, we are seeing a huge triangle here in front of us. This is a right angle triangle, and in this right angle triangle, this angle B is 90 degree and angle C is theta. If we suppose that angle ABC is an isosceles right angle triangle, which means AB is equal to BC, and if AB is BC is equal to BC, then angles in front of us, that is angle C, will be equal to angle A. Angle C will be equal to angle A. Then angle A is equal to angle C, and we already know that B is equal to 90 degree. Therefore, ABC is equal to 180 degree, which will come A is equal to C is equal to 45 degree. So here comes, if we suppose that BC is equal to x centimeter, then AB will also be equal to x centimeter, because both are same, as it is an isosceles right angle triangle. And by using Pythagoras, AC square is equal to AB square plus BC square. And what is AC square? We have to calculate that. What is AB square? X square plus x square is equal to 2x square. So AC is equal to under root 2x. Now using these values, we can find the sine theta, that is sine 45, because theta here is 45. So what is sine? Perpendicular upon hypotenuse. What is perpendicular here? As both the angles are equal, so we can take any of the angle as our base angle. So theta sine 45 is equal to perpendicular here is both is here. This is also x, this is also x, and this is root 2x. Perpendicular is x, and here it is root 2x, which will give 1 upon root 2. Similarly, cos 45 is equal to base upon hypotenuse, and base here is equal to x, and hypotenuse is under root 2x, which will come 1 by root. Last one is tan 45, which is perpendicular upon base. Perpendicular here is x, base here is x, and 1. So these three values, sine 45, cos 45, and tan 45, we can find in this way. And we also know that inverse of sine is cos sec. So it will come root 2, inverse of 1 by root 2. Inverse of cos is sec. It will come 45 degree of 45 degree here also. Cosec 45 will again come root 2, and here cot 45 degree will come 1. So we see that we have 6 values with us. Okay. But this was a case of only 45 degree. What about other degrees like 30 degree or 60 degree? If we take theta is equal to 30 degree, suppose, then 90 minus theta, that is just the other angle, will be 60 degree. In this case, we cannot assume one of the side x and other side will not be x, because it is not a isoscale triangle anymore, isoscale right angle triangle anymore. For that, we have to consider another case, and that other case we can consider by using the simplest of all the triangles. Which is the simplest triangle? Yes, the equilateral one. Okay. So here comes our new triangle, fresh one, which is the equilateral triangle ABC, where AB is equal to BC is equal to CA, and let us consider it as A. Let us draw what we are drawing here. Suppose it is 90 degree, and it is a median and altitude which divides these two angles in equal part, which is angle A. BAC is equal to angle BAD, sorry, BAD is equal to angle DAC, which will be 30 degree each, and BD is equal to DC, angle BDA is equal to 90 degree. These are the things which an equilateral triangle show. These are the properties. Using these properties, we can find out different trigonometrical ratios of different angles. So here the angle B is 60 degree, angle BAD here is 30 degree, and this is the side A, and BD is A by 2. So in triangle, suppose in this triangle ABD, ABD, okay. So in triangle ABD, what we see, it is a right angle triangle. So the hypotenuse square is equal to base square plus perpendicular square. What is hypotenuse? A square. What is base? A upon 2 square. And what is perpendicular? We don't know. We have to find that. So here comes AD square is equal to A square minus A square upon 4 is equal to 3A square upon 4. So AD is equal to root 3 by 2A. Using this value of AD and CA, AD, BD and AB, the values of AD, BD and AB, we can find the rest of the angles. Like for example, we have to find the sine of 60 degree. So for sine 60, we see, where is the angle sine 60? This is the angle sine 60. For this, AD is the perpendicular and BD is the base. So for this, AD is the perpendicular and BD is the base, where AD is equal to root 3 A by 2, and what is the value of BD? It is A by 2. So here comes root 3 by AD by AB. Okay, here was a little bit mistake. The AD by AB, because it is perpendicular upon hypotenuse. I have written perpendicular upon base here. So it is AD by AB. And what is the value of AB here? The value of AB here is A. So what is the value here? Root 3 by 2. So the value of sine 60 is root 3 by 2. Similarly, value of cos 60. For cos 60, what is? Base upon hypotenuse. Base upon hypotenuse. What is the base here? Base here is a by 2. Hypotenuse here is a. So the value of cos 60 is 1 by 2. Similarly, tan 60. For tan 60, what we can take? Perpendicular upon base. What is the perpendicular here? Perpendicular here is root 3a by 2 and base here is a by 2. So it comes root 3. So the value of tan 60, cos 60 and sin 60 are with us. Similarly, we can find the value of cosec 60, sec 60 and cot 60 by just inversing these values respectively. So this was a case of cos 60. Again, for cos 30, what we will do? We can just take the same triangle. All the things will be same, all the values will be same. Just we have to put the angle 30 degree. So here we can write sine 30 degree is equal to cos 30 degree is equal to and tan 30 degree is equal to. For this we know what is the value of sine 30? It is perpendicular upon hypotenuse. Now we have to look into the previous slide. So we can find the value of perpendicular and hypotenuse. Here we see where is 30 degree in the triangle ABD. At angle BAD it makes 30 degree. Okay, so angle BAD is 30. Angle B is equal to 30 degree. So if BAD is 30, then BD will be the perpendicular and AD will be the base and hypotenuse will be the same. So AD is equal to perpendicular and BD is equal to perpendicular, and what is the value of that perpendicular is a by 2 and AD is the base, and what is the value of base? It is root 3 by 2a. So what is the value of base here? We have to write here afresh. Value of base here is root 3 by 2a. The value of perpendicular is a by 2 and the value of hypotenuse is a. So what will be here? P by h. That means a by 2 by a, which is 1 by 2. Here cos 30, it is base upon hypotenuse. What is the value of base here? Root 3 by 2a. And what is the value of hypotenuse here? A, it will come root 3 by 2. And what is tan 30? Tan 30 is perpendicular upon base. Perpendicular here is a by 2. Base here is root 3 by 2a is equal to 1 by root 3. So here just reverting this, we can find other values of it, like we can find cosec 30, which will be 2. We can find sec 30 by reverting the value of cos 30, which will be 2 by root 3. And we can find again cot 30 degree, which will be root 3. So all the values of sine, cos are with us. Okay. So using these values, we can form a table, and that table is this. See, value of sine 0 is 0, because in triangle, if one angle is 0, which this means the triangle cannot be formed, because the value of perpendicular is 0. Suppose this angle is approaching here, this side is approaching here, then this will also be diminished. The perpendicular will tend to 0, which means sine theta or sine 0 degree will be 0. Okay, in this way we are just making this table. One more thing you need to know, that 30 degree is also written like pi by 6. 45 degree is written like pi by 4, and 60 degree is written in the form of pi by 3. 90 degree is written in the form of pi by 2. Okay, so these are the values. You don't need to just by heart it. If you have understood the process from where it came, then you can easily derive the value, and after one or two derivations, these value will automatically set into your mind. So okay, if this much is clear, can we just move forward now? Okay, so moving forward. Okay, so here comes a question, right? What is the question? Question says 5 tan theta is equal to 4. Then the value of 5 sin theta minus 3 cos theta upon 5 sin theta plus 2 cos theta. Okay, 5 sin theta minus 3 cos theta, 5 sin theta plus 2 cos theta. So we have to just write this 5 sin theta minus 3 cos theta upon 5 sin theta plus 2 cos theta. Okay, and we can write here what is this? Tan theta is equal to 4 by 5. We know that tan is perpendicular upon base. So here it is 4, here it is 5. Okay, and for hypotenuse square is perpendicular square plus base square, which is 4 square plus 5 square is equal to 4 square is 16, 5 square is 25. Hypotenuse here is under root 41. We have to just put the values here. There was one more method in which we can take cos common. That method is also easier. That method is like this is the second method. We can just take cos theta common. Here comes 5 sin theta upon cos theta minus 3 whole upon cos theta again common here, 5 sin theta upon cos theta plus 2. Cos theta cancel. Sin theta upon cos theta. What is this? Sin theta upon cos theta. What is sin theta? B upon h. What is cos theta? B upon h. This h and this cancel. It comes P upon B. Oh, this is the new formula. What is that? Sin theta upon cos theta is equal to tan theta. Okay. So here we can write 5 tan theta minus 3 upon 5 tan theta plus 2. And the value of 5 tan theta is 4. So 4 minus 3 upon 4 plus 2 is equal to 1 by 6. So option number 3. This is the way to solve this question. There was another way which I was performing earlier, that is h is equal to root 41, p is equal to 4, b is equal to 5. We can find the value of sin theta as 4 by under root 41 and cos theta as base upon hypotenuse, which is 5 by under root 41. We can just put the values in this equation and find the value of the equation. Okay, so these are the ways, these are the methods. So the next is trigonometrical identities. Let me just correct this quadrant here. It is minus x and it is minus y. Okay. So trigonometrical identities. What are these identities? Why we have to study these? First, to know more about identities, we should know about these quadrants. Okay, I have told you that this is the first quadrant. In this slide, we will only talk about the first quadrant now. So in first quadrant, x is also positive, y is also positive. Keeping this in mind, we can make a triangle here. Suppose this is a triangle. This and this is the angle theta. So sine is perpendicular upon hypotenuse, cos is base upon hypotenuse, and tan is perpendicular upon base. Okay, so here which will be the perpendicular? This is the perpendicular, this is the base, and this is the hypotenuse because this is 90. So perpendicular is positive, base is positive, and hypotenuse is also positive, which means sine theta, cos theta, and tan theta all will come positive here, because this is also positive, this is also positive here, this is also positive, this is positive, this is positive, this is positive. So in first quadrant, Sine, tan, cos. All are positive. This is the first thing. And how it is positive, I have just shown you. Now coming to the second quadrant. What is the second quadrant about? Where is the second quadrant? This is the second quadrant. Where? Yeah, this is the second. So in second quadrant, if we assume a triangle like this, okay, with this angle theta, suppose this is angle theta here, okay. So what is the perpendicular for this? This is the perpendicular. This is the base and this is the hypotenuse. Perpendicular we see is positive, base we see is negative, okay. And what is the hypotenuse? Hypotenuse is equal to perpendicular square plus base square under root, which means it will come positive, because if we do the square of negative, then it will come positive. Then overall hypotenuse is also positive. Overall hypotenuse is also positive. So for sine, cos and tan, what will happen? Sine, which is perpendicular upon hypotenuse, which is positive upon positive, which will come positive. What is cos? Base upon hypotenuse, and base is negative, then it will come negative. And what is tan? Perpendicular upon base. So perpendicular is positive but base is negative, so it will come negative, which means only sine is positive and cos and tan are negative. In which quadrant? We are talking about second quadrant. So sine is positive, cos and tan is negative. This was the case of second quadrant. Now we can talk about third quadrant in the similar way. This is the third quadrant and we are making a triangle here with this angle theta, this angle 90. We see that this is minus x, we see that this is minus y. If we consider minus y as perpendicular, minus x as base, then we see that both are negative, but the hypotenuse again will be positive, because we know that it is perpendicular square plus base square. Square of negative is square of negative, it will be positive. Okay. So here sine, cos and tan. What will the sine? Sine is perpendicular upon hypotenuse. Perpendicular is negative. Hypotenuse is positive. So the value will be negative. What is cos? Base upon hypotenuse. Base is negative. Hypotenuse is positive. So the value will be negative. And what is tan? Perpendicular upon base. Here this is also negative. This is also negative. So the value of tan will be positive. So we see in third quadrant, this is for the third quadrant, sine and cos was negative, whereas tan is positive. Now the last case here, what is the last case? In the fourth quadrant. For the fourth quadrant, we assume this as a triangle. Suppose this is theta, okay, and perpendicular. No, this will be the base, this will be the perpendicular. So perpendicular here is negative, base here is positive, and hypotenuse obviously positive because of the formula which I have been repeating all the time. So okay, now sine negative upon positive, because it is perpendicular, it is hypotenuse, which is negative. Cos, it is positive upon positive, yeah, and it comes positive. And tan, here it is, tan is negative upon positive, because it is this one, so it comes negative. So here we see in fourth quadrant, cos is positive, tan and sine are negative. So what we have seen in all these slides, in first quadrant all were positive, in second slide S is positive, In third quadrant, T is positive. In fourth quadrant, C is positive. So we can write it like this. In first, all were positive. In second, S was positive. In third, T was positive. In fourth, C was positive. So there is a trick to remember these. We don't have to perform all these experiments all the time, making triangles, using P by B or P by H to find the values. We can just remember it like all school to college, which means from a school we go to college, all school to college, or we can just remember it like add sugar to coffee. We add sugar in coffee. So this is a way to remember how the things are positive, how the ratios, trigonometrical ratios are positive or negative in the quadrants, first, second, third, fourth quadrant. So now coming on the identity. What are these identities for? What are these identities which we are talking about since the beginning of the chapter, trigonometrical identities? So there are basically some identities which we have to know. Okay, suppose in a quadrant, suppose this is a quadrant and this is 0 degree, this is 90 degree, this is 180 degree, this is 270 degree, and this is again 360 degree or 0 degree. If we take an acute angle theta, theta is an acute angle, then we can write some values like 0 plus theta, 90 minus theta, 90 plus theta, 180 minus theta, 270 minus theta, 180 plus theta, 270 plus theta, 360 minus theta, or 0 minus theta. So these two values will come in first quadrant, these two values will come in second quadrant, these in third, and these in fourth. How? See, 0 plus theta. Any acute angle above this angle 0 degree, of any acute angle above this will fall in this, or any acute angle below this will fall in first quadrant. Similarly, any acute angle above 90 or any acute angle below 180 will fall in second quadrant, which is this case. Similarly, any acute angle above 180 or below 270 will fall in third quadrant. Similarly, any acute angle below 360 and above 270 will fall in fourth quadrant. Okay, this was the angles and their measurements which we are going to study. So, suppose we take an angle sine theta. What we are taking? We are taking an angle sine theta. What is sine theta? It is perpendicular upon hypotenuse, as we have studied earlier. So suppose it is an angle, and we can make this triangle. Here it is theta, here it is perpendicular, here it is hypotenuse, base. What will be this angle? This will be 90 minus theta. Okay, this will be 90 minus theta. So what we can write? We can write here sine theta is equal to perpendicular upon hypotenuse. Okay. What about cos 90 minus theta? For cos 90 minus theta, what is the value? Base upon hypotenuse. And what is the base for this angle? For this angle, this is the base. So base upon hypotenuse. So we see this value and this value are same. So we can write like sine theta is equal to cos 90 minus theta. Here comes our very first identity. And that was very easy to prove. Similarly, we can do all these things for all different angles. We can just keep tan and cot and sec, cosec. We can just find all these values and we will get different trigonometrical identities related to that. But there is other very important thing which you must know. What is that? We have studied that in first quadrant which is positive, all are positive. In second, add sugar to coffee. Second, sine is positive. In third, tan is positive. In fourth, cos is positive. So what if, suppose we are talking about second quadrant. Suppose we talk about second quadrant and we write here sine 90 plus theta. It will come cos theta. What will be the sign here, positive or negative? The sign is decided by the angle here and the value here. The angle here determines that it will be second quadrant, and in second quadrant as sign is positive, so the value here will be positive. Okay. Similarly, if we write cos 90 plus theta, it will be sin theta. But what happens? Cos. What is 90 plus theta? It will lie in second quadrant. And the value for cos in second quadrant is negative. So here it comes minus sin theta. Understood? So the value of plus and minus will depend upon this angle which we have studied in the previous slide and the value here for which we are operating, not the value here which it is coming, no, for the value here on which we are operating. Okay. So we can write there are different identities created regarding this 90 to 70. These are the angles 0, 180, 360. So for this the value of will change, like it will go sine to cos, cos to sine as we have seen. But for this the value will not change. So we can write here no change. Okay. And these are the basic things which we should know for trigonometrical identities. So what happens? Suppose we take an example here. Suppose we are writing a sine 180 degree plus theta. What we are writing? Sine 180 plus theta. So what is here 180? 180 means no change. Means it will come again sine theta. What it will come? It will come here sine theta. And what is this? Will be sine theta positive or negative? It will determine this. What will define? This 180 plus theta. 180 plus theta will lie in which quadrant? It will lie in third quadrant. It will lie in this quadrant. And in this quadrant the value of sine is negative. So here it will come negative sign. It will come negative sign. Understood? Okay. Now one more example. Suppose we are taking the example of what we can say. Okay, 361. We are taking the example. Sine 0 minus theta. Okay, anything minus theta, anything minus from 0, if we subtract then it will come minus only. That is sine minus theta. 0 minus theta, it will come in which quadrant? It will come in fourth quadrant. Yeah, right. It will come here in fourth quadrant. So the value of sine in fourth quadrant is negative. So it will come minus sine minus theta. Or we can write simply as minus sine theta. Okay, 0 minus theta is minus sine theta. So these were the basic trigonometrical identities. Now, using some formulas which we have studied earlier, the basic formula which I have told you for the trigonometry is, basic formula is Pythagoras theorem. So using that Pythagoras theorem also we can find some identities. Like suppose there are three main identities, which is sine squared theta plus cos squared theta is equal to 1. Okay. So how we can say that this is 1? What is sine? Is n square. What is cos? Right? Remember? In opening the bracket we get, if we add both, we have to prove this, sorry, we are writing this. Okay, if we add both we get, so what is b square plus b square? It is h square. It is h square, so it will come 1. Hence proved. Similarly, there are other identities like and other is so these are the basic trigonometrical identities which we should know and which we should remember. Moving forward, so this is a question here based on what we have studied. Find the value of sine 270 plus theta cos 180 minus theta tan 90 plus theta upon sine 90 plus theta cos 180 plus theta cot 180 minus theta. Okay, so one by one we can just see sine 270 plus theta. It will lie in which quadrant? It will lie in third quadrant, and the value for third quadrant is negative. And since it is 270, which means it will change. It will come cos theta, right? We have seen now if it is 90 and 270, the values of sine changes to the sine changes to cos, cos changes to sine. Similarly, in that way it goes on. Okay, and tan to cot, cot to tan. Second is cos 180 minus theta. It will lie in second quadrant. In second quadrant, value of cos is negative, and it will not change. So it is again minus cos theta. What is third? Tan 90 plus theta. It will lie in second quadrant. In second quadrant, the value of tan is negative. So negative and tan. So it will change. It will become cot theta. Now in denominator, sine 90 plus theta. It will lie in second quadrant. And in second quadrant, the value of sine is negative. So it will come minus. And it is 90. So it will change. So it will come minus cos theta. Okay. Other is cos 180 plus theta. It will lie in third quadrant, and in third quadrant value of cos is negative, and since it is 180 degree, then it will not change. It will come minus cos theta. The last one is 180 minus theta. What is the last one? Cot 180 minus theta. Since it is 180, it will not change, and it lies in second quadrant, and the value of cot in second is negative, so it will come minus cot theta. Okay, so these were the values here. Okay, in this case I have written something wrong here. It will be positive. Yeah, why? Because sine 90 plus theta, it lies in second quadrant, and in second quadrant value of sine is positive, and because of 90 it will change, so it comes here. So writing the values in the formula above, so if we write here sine 270 plus theta, which is minus cos theta into again minus cos theta into minus cot theta upon sine 90 plus cos theta into minus cos theta into minus cot theta. Minus cot theta with minus cot theta, minus cos theta with minus cos theta, and cos theta with cos theta, what is remained is minus 1. So it is minus 1, and thus the value of this equation is minus 1. So in this way we use the identities and the ratios to solve different problems. That was it. That's all for today. Thank you.